In this video, we're working through the solutions to the word ratio practice questions, and here's question 1. The formula we want is the gravitational field strength formula, and if we're looking at the surface of the star, then that r is in fact the radius of the star. G is the gravitational constant and m is the mass of the star. Now, I'm going to be a bit lazy because I'm told that the mass of the Sun is the same as Sirius B. I am just going to put m for both of them. I could put the number in, but I think it's a bit easier if I just put m. And then we also want as we said, the radius of the star, which are those, and then G is the constant and so is the -1, so we don't need to worry about them. Now we're ready to write the ratio. And it's up to you, but I'm going to divide by the fraction and to make that look a bit friendlier there. And now I can cancel the things that are able to cancel. So cancelling the G's, cancelling the minuses. And remember that the M's are the same, so I can get rid of those as well. As you've got to be careful not to get mixed up there. That R on top is the Sun, and that R down there is Sirius B. And this time we're actually putting numbers in. So R of the Sun, 0.7 times 10 to the 9, don't forget to square it, and Sirius B, 6,000, don't forget to square it, and that comes out as 1.4 times 10 to the 10. The next one has two ratios in the same question. It's Sirius B again, and this time it's density to start with. Density is mass per unit volume, and because we're looking at stars, the volume is the volume of a sphere. And once again, dividing by the fraction is the same as multiplying by the fraction upside down. We're now ready to list the variables from all of that. So that's the mass and the radius. Now we're told that in comparison to Sirius B, Antares has 12 times greater mass. So I'm going to say that Sirius B, its mass is m, because then Antares, its mass is 12 times m. And in comparison to Sirius B, it has 1.5 times 10 to the 5 times greater radius. So again, if I say that R is Sirius B, then Antares is 1.1 times 10 to the 5 times R. We're now ready to write the ratio. Again, I'm going to sort out my dividing by a fraction and then cancelling everything we can cancel. Now it's time to substitute our values. So we've got M for Antares is 12 capital M. R for Antares is that. Don't forget to cube. Then Sirius B, R is just that, and M is just that. Now, I've just written out the cube there to make it ultra clear, so we can now cancel our M's, cancel our R cubes, which gives that, and that comes out as 9.0 times 10 to the -15 is our ratio there. Our second fraction here is total power emitted by each star. Now remember, the total power emitted by a star is the luminosity. So this is like the example that we did. So there's our formula. We've got R is the radius of the star and T is its surface temperature. As we saw in the first ratio, the radius of Antares is this times the radius of Sirius B. And then we're actually told the temperatures this time. They do need to be in Kelvin, and they are, so that's fine. So there are our temperatures. Remember, respectively means in the same order. So Sirius B and Antares, respectively, that one and that's Sirius B and that's Antares. And be very careful with how many zeros you've got there. Okay, so there's our ratio, cancelling everything we can cancel, all the constants there. We're ready to substitute already there. Now be very careful you don't forget any of your powers there. So there's the radius of Antares squared times the temperature, surface temperature to the 4, radius of Sirius B squared times surface temperature of Sirius B to the 4. Squaring the bracket there, we get this to be super clear. Now we can cancel our r squareds, and if you work all of that out, you should get 1.1 times 10 to the 7. Okay, this next one looks like an astro question, but it's actually a thermal question. If you're thinking about the speed of particles, then it's related to their temperature. Now, it's a bit dodgy here because it should say root mean squared speed of the electron, or at least average speed of the electron, because that's what they're expecting you to do. And the formula we have for that is this one. Now, we obviously don't know what the average kinetic energy is. However, our other formula for average kinetic energy is this one. And so I'm sure, as you're familiar already, we can get a formula for the root mean squared speed of the electron. Okay, so the speed of our electron, this is the formula we're going to use. T is the temperature in Kelvin, and m is the mass of the electron. Okay, so 3 is a constant, obviously. K is the Boltzmann constant, and m, it's an electron both times, so m is the same for both. The temperature is the thing we've been given, so it looks a little bit odd, this one, but we are going to do it just the same way. So the temperature for this one is obviously 10 to the 8 Kelvin, and the temperature for that one, 2.7 Kelvin. So we're ready to write our ratio now using this formula here. Now, I don't know how happy you are with square roots, but just hold your nerve. I've got a fraction divided by a fraction, so I'm going to divide by my fraction again. There we go. Now, I'm going to cancel. If you want, you can do out your square roots there, but I'm going to leave it and cancel at this point. So I can cancel my root 3's, cancel my root k's, and remember an electron in both cases, so same m, so cancelling my root m's. So that actually comes down to just this, being very careful not to mix them up, get them the right way around. Putting the numbers in, it does need to be in Kelvin, remember, but that's okay because we've been given temperatures in Kelvin. And that comes out as 6.1 times 10 to the 3. Never round to one significant figure, remember, unless it's an absolute uncertainty. Always round those to one significant figure. In this type of question, if you want to write out everything on your calculator, that might be the safest thing to do, just to make sure you don't round to the wrong number, just to prove that you really did it.